Well, hello everyone. My name is Josh Furman. I work for Meyer Tech Support. And welcome once again to the Spacemap Go Roundtable series. We're really excited about these roundtables tonight. This has been a fun series. And with me, as always, are an esteemed list of panelists. And tonight I'm working with Mr. Steve Bush, Senior Technical Product Manager of Video. And throughout the rest of the Roundtable series, we might have a couple other panelists. All of these panelists will be helping out and answering your questions. And Yanina and Jose actually have been doing double duty, and they've been assisting our colleagues from Mexico and Meyer Sound, Mexico, and doing the Spanish version of this roundtable as well. So you can find more information about the Spanish roundtables on our Facebook group, as well as, I believe, on the Meyer Sound website. Couple more resources. We are recording this roundtable, and we've just posted the second roundtable that we hosted last week. And so you can find all of them on the Thinking Sound YouTube channel. Roundtable 1 was talking about what a space map is and how to use it. Roundtable 2 is implementing Spacemap Go into your workflow. Talks about saving your work and what you need to do when you get onto the job site. And then Roundtable 3 today, we're going to talk about how to prepare to implement a Spacemap Go system. And we also have another amazing resource, which is the Spacemap Go help website. And this, you can consider the operating instructions for Spacemap Go. There's a ton of information on it. And if you do find something that you need a question answered on, or if you have a feature request or a bug report, we ask that you go to meyersound.com/contact and that you fill out a software support form or a technical support form if you have a general question. That will reach most of the team. And we want to hear feedback about this application once you start using it. And we want to hear your notes, your thoughts, so that we can make it better for you. And with that in mind, we're going to start Roundtable 3. And Roundtable 3 is about implementing Spacemap Go. We're going to sort of continue our journey. Last week, we were in our house building a 5.1 system using a very basic loudspeaker layout. And this week, we're going to take those same concepts and talk about implementing them in a real world system. And so today's topics, we're going to talk about planning for your system for Spacemap Go. So with Galaxies, since Spacemap runs on Galaxies, there's some things that you might want to consider. We're going to just give you some of our tips and tricks when building systems. That way it's easier for you to implement Spacemap Go. And we also are going to talk about how to deal with loudspeaker systems and subsystems, things like front fills, line arrays, and subwoofers, all of the type of speakers that we would run into in subsystems of our loudspeaker system. So we're going to do that, and then hopefully we'll have plenty of time for Q&A and discussion, and then we'll open it up to talk about whatever you want to. So here we go. So you can work offline with Spacemap Go, as we mentioned last week, and really you can do almost everything. You can design your sound system, then you can pre-label all of your channels, and you can do all of the boring work, as it were, of just labeling things and making sure you have things in the right order. Then you can also use the app and pre-build your space maps and your movements if you wanted to. And then you could even pre-program shows. And we talked last week about mainly from when you get into the venue. We talked about saving your work, building a mix, and saving snapshots. But this week, most of this stuff can be pre-planned, and you can run it all offline and do all this work before you even step in the venue. And so the first thing we're going to talk about is the room. So typically, if I'm in a room, I need a loudspeaker design. And I would use Map3D to do that. And I would design an immersive sound space. For more information on designing immersive sound systems and some of the rules of physics that you need to adhere to, please go to the help website. There is a section for sound design. And that is really beyond the scope of what that we're going to talk about today. But ideally, I would design a loudspeaker system for a room, and I'd make sure all of the seats are getting coverage and that they are in an immersive environment. So here we go. This is that system, and we're in a ballroom. This would be like a medium-sized venue. And what I have here is a main system consisting of 8 leopards on each side. And then I have a gradient array of 900s on a left and a right. And on top of that, I also have a frontal systems. And right now in the industry, a big buzzword is frontal. You could easily build a space map to implement a frontal system. And so we'll do that as well. Then, of course, since we want a fully immersive room, we are going to add side surrounds as well as overheads. And those are X40s. And in our example, we also have rear surrounds as well as rear subwoofers. We're going to take our loudspeaker layout and we're going to make a space map of it. And we're going to utilize it to control this loudspeaker system. And as we mentioned last week, a space map is an abstraction of a loudspeaker layout. So this space map does not have to look like this. It could look completely different to control this system in a completely different way. And that's what's exciting about Spacemap Go is you're no longer bound to the physical location of the loudspeakers. And it gives you the opportunity and the freedom to mix a system in a very interesting way. That all comes down to planning. And the first thing, of course, if we're looking at a normal signal chain from inputs to outputs, the first thing you're going to look at is your inputs. The first decision that gets made when designing a sound system is what do I need to move and what needs to go where. So typically with a mix console, you'll have a main left and a main right. And most of the time, that does not need to move. Anytime I send out of my main left and main right out of my console, I want that to go directly into the PA and never move at all. And so that's the first decision. I first decide what inputs I want to use that are just going to be static and stay where they are. And then I decide what inputs am I going to send that are dynamic? What do I want to move around the space? And so that all depends on what content you're dealing with, what you're working on. And that's an artistic decision. But from a technical standpoint, what we really care about is just what inputs we're using. And we need to decide what's static and what's moving. And so it's as if we plugged 8 XLR cables into our Galaxy and we decided that our console, our first 2 are going to be static and the rest are going to be movement. Well, the next thing I do is go into the iPad app and I actually lock out those channels on the Spacemap Go iPad. As we said before, Spacemap Go just controls the summing matrix of the Galaxy. So if I initialize my system, I get up and running, the first thing I want to do is lock out my static channels and make sure that the matrix is static and ready to go. This way, Spacemap can't even touch those channels. And we'll show you how to do that. The next part we want to talk about is output order. So when building space maps, the Spacemap Go application makes building space maps very quickly, but it does something very interesting in that if you add a speaker node, it uses a linear order number. So it will start on output 1, and if I add a second output node, it will put it on output 2. So if you plan your system right, you really just have to touch your nodes into the space map and add them, and then you will have multiple nodes, and it will basically lay it out for you. And we'll show you how to do that very shortly. And then one other thing to consider is sometimes you have to deal with systems and galaxies that have multiple outputs, or you're dealing with line arrays. And there are a couple ways to deal with line arrays. You can have a speaker node for every single output, but you can also use one output from a space map mode galaxy and feed that via AVB to a normal mode galaxy that is feeding line arrays. In order to do that, you need to understand how the signal processing works within Galaxy. And you need to understand where to pull signal from. So there's a couple places. Every single galaxy, whether it's in space map mode or if it's in normal mode, every single galaxy is broadcasting its input splits as well as its outputs over Milan AVB. And the input splits are very interesting in that they are broadcasted post input processing, but pre-matrix. Since Spacemap Go is controlling the matrix, if I don't want something to be affected by Spacemap Go, I can simply just pull that feed from the input splits and have a static feed. Also, we have the outputs, which are being broadcast simultaneously from the physical connection over Milan AVB. And those are post summing matrix and post processing. So, what this allows for is you can use your input splits for your static console feeds, and you can use your outputs as dynamic movement pieces. And what the way that would look really in the real world is I'd have a mix console and I'd send out some main left and main right, and I'd have some movements or aux sends that I want to move around. I plug all of those XLR cables into my first galaxy in space map mode, and that first galaxy in space map mode would control some loudspeakers that are local to it, but over Milan AVB, it would also be broadcasting its outputs as well as its input splits, and I could simply, just with Milan AVB, take the console feeds on the input side as input splits, and I could take the outputs via AVB and put them on the inputs of this guy. And I could have two separate pathways to send to this normal mode galaxy that then is controlling all of these loudspeakers. And that makes it very simple for Spacemap to control a line array, because then all I need to do is put a one node as an output node from Spacemap, and anytime level or sound hits that node, it sends it via AVB to the normal mode galaxy, which is then routed to the line array. And I know that might sound a little confusing, but we'll talk about that in a second and show you what that looks like within Compass. But in order to deal with other fill systems, what we want to do is use derived nodes. And in our first week, we talked about what a derived node is, in that it derives its audio information from the speaker node that it's connected to. And so here's that example again. We have a left and a right, which are our main outputs. And we use derived nodes to link other outputs to the main left and right. In this case, we have 4 front fills across, and then we just add them in. And then we have 2 side fills in this example, and those are connected to the main left and main right. And now that they're all linked up, all I do is add a triset. And now as I pan left and as I pan right, those subsystems receive the same energy that the main left and the main right speaker is receiving. So this allows for incredible control and flexibility of space maps and of your subsystems. The first thing we're going to show is how to set up this galaxy. So here's our example system in our loudspeaker environment. Here are our galaxies. And so in my ideal system, currently I'm in a hotel room, so I don't have hardware on, but I can do all of this prep work ahead of time. And I can decide where I want my console feeds to come in. So I have them right here, console left and right. And then I can decide even further how much inputs I want. And in my system, I have 3 galaxies. So I can use these first 2 galaxies in space map mode. So I'd have a total of 16 analog inputs or AES inputs. But since I could also use 32 Milan inputs, as we talked about in previous roundtables. And what I'll do is would basically just set up my system, get it ready to go. I would name all of my outputs, and I would decide where I want each thing to plug in. I would maybe build a line diagram and have it all working and wired up the way I want it. And so this is all the pre-programming that could be done. And then the next thing I'd want to do is decide how to feed my line arrays. So in this case, what I'm going to do is go open another normal mode galaxy, and I'll go into settings. And if I was connected to hardware, I would simply just click this and decide where I would pull the AVB stream off of this first virtual mode galaxy. And if I clicked AVB here, a window will pop up. And this only works when you're connected to hardware, because it's different with every single piece of hardware. But basically, my galaxies would appear here, and I would first pull the input split off of this first galaxy, and I'd take the input split of these 2 channels, and I'd route them right here. I'd take this input split and route it to channel A, and channel B's input split from virtual galaxy 1 to channel B, And then I would simply just set up my routing for my line arrays. In this case, I have leopards, 8 leopards and 4 channels of processing for them. And we can see that channel A, main left, would get that there. And I'd also send it to the subwoofers. And then same thing for the right channel. We would have 4 channels here and to the right. Now we also notice that I've duplicated that routing path, and that routing path is actually the outputs of this galaxy. So this would be my static feeds. Anytime I sent to my left, it would always go here. And these outputs are actually my space map outputs. So anytime a space map is involved, and anytime I'm moving the summing matrix and want to feed those line arrays, I simply just build a space map that has this output in it. So that's how the galaxy's set up and ready to go. We talked about then saving system snapshots with that as well. But let's jump back into our iPad and get this set up on the iPad. All I would need to do is go to Settings. And you can see here that since I labeled my outputs in the galaxy, that they all line up here. And I could start going in and creating my loudspeaker layouts that I want to use for the show I'm working on. And in this example, we'll just build the frontal system. So I know I have 5 loudspeakers across the front. And I know that my first channel, as I tap in, is main left array. So there's my main left array. And then there's my main right. And then I know I have 5 more nodes. So here we have a front left inner. So I'll quite simply put it in here and touch and hold to drag it over. And then I'll add another one, which is front center. So I'll put that guy in the center here. And let me move this over. And then I know I have another front right inner. So there it is there. And please note that this is not, the prettiest example. And we have front outer left. So I put that in the wrong place. So I'll just tap it over here. And then I'll add one more, which should be our front outer right. And there we go. I could spend some time and quickly make these look even. And there we have our frontal system. That includes our line arrays. And we know that line arrays, 8 leopards versus 1x40 might be a little different in SPL. So I'll just trim this guy down by, let's say, 6 dB. I would, of course, measure that when I'm tuning and adjust that as needed. And then all I would need to do to create a frontal system is add some virtual nodes. We talked about what virtual nodes were, so I'll just add a few here for control. And I'm going to add another level of virtual nodes here. And as we said before, virtual nodes can link to multiple speakers, and any speaker node can send to multiple virtual nodes. So I'm just doing this very quickly as an example of how to get up and running quickly. But because I plan my outputs accordingly, I now know I can easily add those speaker nodes quite quickly and be up and running with a space map for my system very quickly. And actually, I want to make this guy like that. And we'll add this guy and this guy and this guy and this guy. I edited out. And then let me add one more here, and we'll do this, 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 and this. And we're using virtual nodes, and it gets made right like this. And quite simply, I can use the auto build feature within Spacemap and just build off of these virtual nodes. And now, within a few seconds, I have a frontal space map, and I will simply just drag it across and make it a little bit prettier. And I'll delete a triset. There we are. I might just arrange this and make it nice and neat, and then I'll rebuild my trisets to where it gives us a little bit more control. Now this looks horrible, and I would of course spend some time to make it look a lot better, but you get the idea. And I'll just delete my trisets and then build it again. And there it is. And if I test this, we can now see that we have a frontal system, and I can utilize it and use it to control the system in various ways. And I can use virtual nodes to control the frontal system in crazy ways. So that was an ugly version of a space map, and I've actually, pre-programmed a couple that look a little bit prettier with our actual loudspeaker system. And typically, what I do when I'm designing for a system is I'll build one big space map that looks like the location, physical location of the stage or wherever I'm working. And in this case, I built our template example that we just showed. And I quickly have a system here, and we'll notice that we use the stage as a frontal system. If I had a singer or something moving across, we can see that as I get closer to the speaker nodes, we notice that the audio level for each one of those nodes expands and contracts. And then since we can utilize virtual nodes, if I simply want to make that sound a little bit wider in the front, I can move it back and have it move across as well. And the best part about this space map is I also can use the space map to move sound around my whole entire system. So I can have my singer move around, and with the touch of my finger, I'm controlling the whole entire loudspeaker system. I'm controlling the frontal, but I'm also controlling the surrounds. From there, I can duplicate this space map. And so I'll just duplicate it real quick. And if I wanted to, I can go into the duplicate that I made. I can delete things or add things. Let's say we want to build a space map just with our overhead speakers. So I'd quickly just delete all of my speaker nodes. Or here we have a blank map. And so I'll just add 4 overheads. I have 4 overheads in my system. So I have 4 speaker nodes, and I'll just set their outputs to be my overheads. So overhead left. So overhead right. And here we have overhead right number 2. Oh, wrong patch right here. And here we have overhead left number 2. There we go. And let me just add a virtual node real quick and link these speakers together. And within a matter of seconds, we have our loudspeaker layout just for our overheads. Let me add some trisets. There we go. And I'll just drag it out to make this whole panning surface just my overhead speakers. Here we are. And now I have a space map, and I'll rename it, and we'll just call it overheads. And this space map will only control these loudspeakers, and that's useful for things. Let's say I have a channel here, and I want to have my frontal system that I made. So I made another frontal system, a little bit more, that looks a little bit better, and I will add my overhead system here. And now I can use this space map to control the frontal system. But let's say I want to just add that same sound into my overhead system. Here I'm controlling the overhead system, and I can actually mix in how much of the frontal system I want versus the overheads. And I can decide how much energy I want. And as we move into the stage, I can control the frontal system differently. The possibilities are really endless with the building space maps, but let's talk about front fills real quick, and then we'll take your questions. So within my frontal system here, or my full sound system that I made here, I forgot to add my front fills, or actually I did add my front fills. So we'll just go to derived nodes, and you see that they appear as outputs 25, 26, and 27. I'm gonna go into Compass, and at the last minute, I decided I needed front fills in this system. So I plugged in front fill 1, front fill 2, front fill 3, and front fill 4. And we can see that the labels within Spacemap Go changed. For now, I'm gonna actually just delete them and we'll add them back in. All we do is add what's called a derived node. We talked about what that is, and because I planned my output order in proper order, it instantly knew that output 24 was the next output that I need to use. And because I did my pre-planning, quite simply, I just tap in, and then I need to decide where this front field is getting its audio level from. What I do is just select the speakers I want it to get. So my main left is right there. Chances are the only audio I want that front field to receive information from is that main left. And then we can just simply move on to our next front fill. So I'll just select out of here. I'll select out of here and add another front fill here. And we'll add our next front fill here and front fill here. And for this front fill, it's a little bit closer to our center speaker. So I'll add my center speaker and the left speaker in. And if I want to, I can simply trim out how much I get from each one of these. So let's imagine they're perfect together. So we'll just do 60 dB down from each. And now, if I test this real quick, anytime I add audio level to this main speaker or the center, we notice that the derived node of these front fills is also receiving its level. And so we can continue that process on, and we'll add this guy to the center, and we'll add this guy to the main inner right. Oops, so I don't want that there. So I'll unlink it, and I'll quickly add it to my line array output. And we'll do the same for this one, this guy. We'll just put that one there. And if I wanted to, I can just click exit selection. And now I've added our front fills into our system. So that's how you deal with fills. You can use derived nodes, and you can do it in very interesting ways. I think that's about it. And I see we do have some chat.
For speaker nodes, derived nodes, and virtual nodes, tap the 3 buttons and talk about assigning different channels and level for each of those.
Oh, absolutely. Yeah, so let's go to speaker nodes first. We're gonna just tap a speaker node right here. Here's one, and it ended up being the overhead left. So what I could do is quickly tap the 3 dots, and there's a couple options that pop up. And the first option is called set output, and the next one is trim. If I click set output, this is where I could repatch my system. And it's important to note that speaker nodes are just representations, so you can have multiple speaker nodes. Let's say I want that speaker node to be my main left array. So now, anytime audio hits here, gets close to this node, it will actually feed my main left array. So my main left array is represented on the Spacemap here, but also here. And you can see how this can be really interesting, and you can program some very neat things very quickly.
So can you assign a speaker node to more than one output?
No, you can't assign a speaker node to more than one output, but you can assign a virtual node to multiple speaker nodes.
So only one output per speaker?
Yeah, so a speaker node represents an output, but you can have speaker nodes of the same output. Does that make sense?
Yes.
Okay, so let's make a super simple map. I'm going to add four speaker nodes. I could simply just go into the ... here and set them all to the same output on the galaxy.
So when you pan around, you won't be panning.
So when I pan around, I wouldn't be panning. But let's say I had a line array in my galaxy, and my first 8 channels were the same line array, Just for this example, guys, I'm going to go in, and this is another way to deal with line arrays. I'm going to use, call this leopard 1, or let's just call it array. Array 1, channel 1 and 2, 1, channel 7 and 8. So now we have that in Compass, and I just labeled it. All I would simply need to do is add those 4 speaker nodes, 1, 2, 3, 4. Here we go. We're going to use these 4. This is the top of our line array. So set output, and we'll make it array channel 1. And then this is our second set of speakers in our line array. There we go. And then this is our third set of speakers. And this is our 4th set of speakers. And I could simply just add a virtual node. And remember, a virtual node is a multi-purpose node that evenly distributes the audio level between multiple sources. So I could simply just add that virtual node, and I'd add a couple more virtual nodes just to show you how this would work, and add a triset amongst them. And we'll click test, and we'll notice that as we get closer, that the line array, the energy of our line array, and let me find those outputs on the matrix, we can see that they're evenly getting the same amount of signal, and they're being distributed that way. So that's one way to deal with a line array if you want to.
Have you ever built a space map without the virtual node, but had the 4 nodes for the pairs of array elements and panned between them and listened?
Yeah, so it sounds cool. It's very useful for effects. So let me just delete that virtual node, and let's just let's add a couple virtual nodes actually. So we'll just do this, and then, yeah, I think we'll do that, and we'll see what this builds. So let's just click build trisets. And now we're using this space map, and I'll make this bigger so we can actually see what's going on. So let's say this is our top of the array. This is the middle of the array. And this is the bottom of the array. You can see that this could very well be a line array. And now we can crazily control the level in the line array if we wanted to, because a space map is an abstraction of a loudspeaker layout. It just so happens in this example, our loudspeaker layout is a line array. And so people do this all of the time in shows for sound effects and stuff. They'll actually make a space map of a full line array and move high frequency content up and down it. And it has this zippering effect. So it's used as an effect. I would never do that on a rock show or anything, but it's useful. It could be useful, and so you can do it with a space map. The other way to deal with a line array is to have a single output. Let's say this is, I'm going to set my output to, let's say this is the top of my line array. And then you can add derived nodes for the rest of your line array and link them. So I'm going to just link these guys back to the top box, and I'm going to set their output properly. So I know that, yeah, actually Spacemap Go did it for me because I laid it out properly. So automatically, this is my first channel, which that's my top of my array. And then because I laid out all of my speaker selection right, it went with the next output, and then the next output, and the next output. So very quickly, you can now control a line array with a derived node. And now we'll just build a quick little example to show you this. I'll just add a triset from here, here, and here. Here's our triset, and now we can see that our line array is getting absolute level. So anytime we hit 0.4 dB to our top output, it's going to send 0.4 dB to the other nodes connected to it. So that's another way to deal with line arrays if you don't have a normal mode galaxy. The way we're doing it in this example is we're just taking this one speaker node on this galaxy, which happens to be output 1, and then output 1 of this galaxy over AVB gets sent to a galaxy running in normal mode right here and sent to these loudspeakers. So here, and just to show you what that looks like in the matrix, I'm going to add this to a channel. So let's go back to Spacemap. Let's say I'm on channel 10. Actually, I'm going to go back and go to channel 8, or let's do channel 2. Why not? I add a space map that I made for this loudspeaker system. And let's just put the audio energy right around the main array. And we can see that on channel 2, our matrix levels have changed. And we can see that output 1 of this matrix is at 0.1 dB. And that would mean that 0.1 dB is coming out of this output channel. And then over AVB, I would simply just connect that output channel to this galaxy here, and it would hit my line array. So this output node right here, this output node right here is representing a whole line array. And we're just utilizing the Milan AVB to distribute the signal far beyond our galaxy.
Anybody just simply take like the direct outputs of their console and use them as the inputs for a Spacemap system?
Oh yeah, all the time. And speaking of that, one thing I forgot to cover, so let's just do this now. Let's talk about static feeds and when we're planning on things, how to deal with them. Let's imagine for a second that my console was plugged in here, and the main outs of that console, main left, and main right.
Those are console outputs.
Yeah. Yeah, let's just say they're my main left and main right. And I notice I have some stuff in here, so I'm gonna just quickly clear the matrix by pressing this button. In my real world example in Compass, I can just go here and route my console or my main left to this output and my main right to this output. It's also gonna feed subs. And these are my static outputs, and I never want them to change. In order to make sure that I don't touch them within Spacemap Go, we can see that the cross points populated. On every iPad I'm working with, I can go into locking control and then decide, let me move my chat out of the way because I can't see it. I select the channels I don't want Spacemap to control. And so I can decide however many channels I want to use that are just static routing. And in our sound system, we could even do fun things like a quad. So if we had a rear left and a rear right, and we didn't want it to only move, we could do that. But in this case, let's just say we have main left and right. So we could do that, and then we click enable. And once we do that, if we go back to our mix section, we'll now notice that these two channels are red, and we can't touch them within the iPad. I can touch this guy perfectly fine, but I can't touch this level. And so Spacemap Go is effectively locked out and
Can
can't
you go back to the channel view and change the matrix levels?
No, you would have to unlock it first, go to channel, and then mess with it. If you wanted to do that here, I'm going to add a space map and just start moving with my finger. Actually, let's just put a trajectory on there. Here we go. And so now we can see that that trajectory is moving the matrix levels of the next channel over. And we can also lock that out. Let's say we want that to always move and we never want someone to touch it. I can go into the iPad app, and now I can't manipulate that without unlocking it. It's client-based too, so every iPad can be locked out in different ways. And so this is useful for when you have like a DJ and you want them to move it around their own space, their own sound, but you don't want them to mess with your main left and right mix. You can just lock them out of it, and they don't have to worry about it. So that's a useful feature. You can also lock out the mute and the solo buttons as well for various mixing applications.
So does that mean that no matter where, the person is, like let's say the person who has the microphone and they're walking around, the sound that's coming out of the left main and right main are always going to be the same? It's not changing its sound pressure level based on where the person is. Is that correct?
Right. So let's say like I'm on my mix console, I just have a main left and right. So if I have that vocal sent to that main left and right on the mix console, it's always just going to hit these two inputs and go to these outputs because they're statically routed that way. And we could then take that vocal, send it down an aux on our console, have it hit channel 3 of the Galaxy. So I just plug in another XLR, and now I can move the vocal around and still have it be out of the main left and right, or wherever I put my static routing.
Oh, I see.
Does that make sense?
Yeah.
Do you want to talk just a moment, Josh, about different types of inputs and different kinds of things that you might do with them, like, for instance, a guitar channel, a vocal channel, and a stereo keyboard?
Yeah, totally. So let's just build something out. So we have our main left and right that are our engineers using, and that will be static.
In a black tracks channel.
Oh yeah, black tracks channel. Okay, so let's say this guy, we then set in an aux, and this is our vocal. Our vocal channel could then, we can program it to move around, or we could just use it as a frontal system here. I can mix it live, or I could just add a trajectory, touch the iPad, and let's say we want our vocal to do some fun things. Most likely you would move the vocal around with your finger if you're doing live things. And then let's say channels 4, let's say this is our guitar. So I'm gonna just touch up top and label it guitar. And I can add a completely separate space map. So I would decide where I want my guitar to go. So I'll have a frontal system. Ooh, that map, I didn't complete that space map, did I? Oh yeah, so I'll have a frontal system here. And then let's say I want my second space map on that channel to just be our mix map, or multi-purpose map. So frontal plus surrounds. So now I could crossfade between the space maps and have different energy level. In this example, I have my overheads here. So as I move my position, I can move from the overhead system and fade it into the frontal system. So I could then put my guitar on a quick little path and decide how much I want in each system. And it will be off on its merry little way. I could speed it up if I wanted to, or mix it live. And the same thing goes, and we can do that with, let's do this with keyboards and talk about linking. So we'll say this is keys left. Excuse me while I type fast. And we'll say channel 6 is keys right. So this is a stereo track. And so what I can do with Spacemap Go, let's say we have this keys, is I'll do the same thing. I'll add the frontal space map. And then I'll add let's add just the surround space map here. And you'll notice that you don't see any speaker nodes or anything on here. Very simply, what you can do is control how much information you want to see within the app. And so I click settings down here and go to space map and trajectory display. And I personally like to keep off speaker nodes and virtual nodes. And then I keep on show weight dB indicators. And what that does is that allows my space map to only show things when they have level on them. So here are all my loudspeakers, but it just helps give me a visual representation and tells me where I can see my sound and where it is, and how much energy is coming, how much audio level is coming out of each speaker. So yeah, this is our keyboard 1 position. But I could also set it, and I can add linking. So let's say I have a stereo, and I just want to make that signal mono. Now, by linking, I'm now controlling my stereo pair of keyboard channels together. I could also manipulate the linking behavior. So if I do mirror X, it will mirror itself on the X-axis, and we can see here that as we move left and right, I'm just touching the left channel. We can see it's controlling in a different way. I could do mirror Y, and now along the Y-axis we're moving, but we're staying the same on the left. And so there's a lot of fun linking behaviors you can do. So now this is mirror XY. So now this stereo track can be played in different areas. Yeah, and then if we had something like a black tracks device, first thing we'd do is we'd set up black tracks. And the way you do that is go in here. And this is going to be worked on the help website, because I'm not sure how much information we have on there, but you click enable. And you, of course, we talked about last week setting up external controllers and how to set it up. But then you can actually use, this is a very complex topic, but anyway, you have your X, Y, and Z values, and those translate to the dimensions of the space map. And the Z value is actually for the vertical value. And so let's say this is our vocal, and that person is using a tracking system. Here we go here. So what I can do now is have my first space map, which is just the lateral and the frontal system. And so we can see here that if I go overhead here, we can see that my overhead speakers aren't being energized, and I don't actually have them drawn within the space map. And I'll use my second space map to just have my overhead system. Here we are. And now we can actually program black tracks to control the crossfade or the height of the system. So black tracks, of course, works in X, Y, and Z planes. And the Z plane would translate for us to the space map crossfade. So we then would have a lateral space map that's just our side wall space. And as that person were to, let's say that that person flew up into the room, I could then manipulate the cross point and now decide how much percentage of audio energy or audio level I want to feed to my overheads. And now I'm completely only in the overheads. And we can see them here on the matrix. And as I move down, we can see that they would then go away and just go back into our space map. So can the channels of a stereo track be controlled independently? Yeah, totally. So without linking my stereo track, let's go back to our keyboard here. Without linking a stereo track, I can just put non-linked, and now my keyboard left can be in this corner and my keyboard right can be in this corner. Or if I want, I can just put a frontal space map on and have my keyboard left here.
Point to the link button.
Yeah, here's the link button, and if I tap it, it gives you a whole bunch of options. One of them is not linked. So I plug in a stereo track of my keyboards like this. I can link them and have them be controlled with linking, but I can also keep them. So let me do that real quick. Here's a link to where they're behaving in a mono, so acting the same. I'm just touching this channel here, and let me unlink it, and now I have independent control of each channel. And because each channel can have completely different space maps on it, I can make this guy just be in the fronts, and this guy can be doing whatever it wants. Oh yeah, when tuning and calibrating an installed system, what measurements should be made? Same as ever, or are there new considerations? How would you enter the derived desired level adjustment directly in Spacemap Go via the various feeds of the derived node? Or, okay, that's a lot of questions, and let's take the first one. What measurements should be made? Here we are in our room. Of course, I would still need to be doing on-axis measurements of the speakers. And of course, this room is very symmetric, so I could tune an on-axis here of this lateral and most likely copy it over. So you tune on-axis for frequency and phase response as usual. The other thing is, since this is indoors, most likely that the speaker will have a little bit of boundary loading. So you would want to adjust that in your tuning. That's all done by an on-axis measurement. The other thing I would do is maybe place a series of microphones down on axis and maybe one directly off axis. And I would turn this whole wall of speakers on and see how much low-mid buildup there would be. Because at some frequency between the distance of this speaker and the distance of this speaker, they're summing together. And I might adjust the low mids to match my response curve, whatever curve I'm using, to make sure it's equal and that they sum together quite nicely. The other thing I would do to sort of verify positioning would be to try and find the standard, 6 dB down point. Where does the horn of this guy lose its coverage? At what angle from the wall to the bottom seat? And hopefully you've designed your system enough, and there's more specific guides with designing immersive systems And the rules for designing an immersive system are a little bit different because normally in a loudspeaker system, we're designing a system that doesn't really overlap. So here we have a loudspeaker like a Leopard. We would design this line array to cover as much of the room as possible with as minimal overlap between the left and the right. So we have nice, even summation amongst our audience area. Well, with immersive systems, overlap is kind of important because it allows for immersion. And so what we would actually do is point our loudspeakers to a center point within this area, and that would be our immersion zone. Now, the spacing and the amount of density of the speakers and stuff, all is about system design. And I think eventually we will have a roundtable talking about designing for immersive systems. I would measure it the same. And then for subwoofers, when I'm delaying mains to subs, you sort of just pick the mains that are and what subwoofer they're closest to. So all of these guys in this quadrant here would most likely get time aligned to this subwoofer, and then all of these guys in this quadrant here would get time aligned to this subwoofer, and then this subwoofer here is in the rear, so I'd probably time align my rear surrounds to that guy, and these guys to that guy. And because the goal is to make sure that when you move a sound around, it's full range all the way across the room. It's sort of a mix of both. You have new rules, but the same rules for sound system optimization apply. You know, you're going to do on-axis measurements and you're going to do off-axis to just make sure your coverage area and you verify that your design is functioning as expected in the room. In terms of response curves and frequency response, depends on what you're doing. If you're doing a rock and roll show, that curve is going to look a little bit different than you would a Broadway show. But if this is a cinema room and it needs to be tuned to the X curve, you can tune it that way as well. The response curve is really dependent on what you're doing, but the fundamentals of verification and optimization are pretty much the same. Would you agree, Steve?
Bob has created a lot of materials that I'm transposing into the help website. Big clues for model selection, wider.
Yes.
For the laterals, you want a really wide speaker that's not got very much vertical. For the overheads, you want really wide vertical and horizontal.
Yeah, so here we have a space map I designed to where I have 4 virtual nodes that replaced my sort of overhead location. And so let's say at all points I was using this space map and I just had it to where every time I moved it, I wanted just these speakers to work. In that case, these are acting like a speaker, but because this map is a multi-purpose space map, I can also individually use them. The beauty of this is that the virtual node allows for weighted distribution. So you really don't have to worry as much about the low mid buildup. You still do, they will, still some, but you can evenly distribute the weights of these speakers, or you can decide how much audio level is arrives at each node. So let's say this guy, instead of being 25% of the energy, I'm sorry, I'll click one here. Let's say this speaker right here, instead of getting 25% of the energy, let's say I only want it to receive 30% of the energy. Oh, I typed in the wrong number. And now, Spacemap Go, you'll notice that these numbers here changed. And now we can see that the rear right is receiving 30% energy, and the rest are receiving 23% of the total energy. And so that gives you really cool options to decide how you want to taper things and come up with really fun use cases. So, and the power of the virtual node is just, can't wait to see how it gets explored. But something I would use this space map for is for quad reverbs. So I would put a reverb on a channel and I'd put it, I just place it there statically. And then I'd add another reverb on a channel for my console and maybe for my drums. And I'd put it here. And then I'd put my space map here. And then I could have a quad reverb, and it could be 4 various reverbs. And like in our mix example that we've had, let's say this channel is our let's say this is our drum reverb. So we'll just name it drum reverb. Excuse my spelling. And then we just add that space map in. And now that drum reverb, let's say it's a stereo reverb. I'm going to use that same space map and energize. This will be my left, and then this will be my right drum reverb. And I'll just add I'll change the space map and make it be this quad. And here's my right channel. And now we have here's our drum reverb 1, and here's our drum reverb 2, and they're stereo. So I could send a stereo reverb. And so, yeah, there's a lot of more things to explore, and you can definitely go to the help website for that. And Seth had a question about password protecting the locking mechanism. That currently isn't implemented yet, and it is client-based. And it's client-based for a good reason. You can set it each iPad up differently, and I do think password protecting might be a useful feature, and so you should definitely put in a feature request. But what's cool is, let's say I'm working in a big theater or install, and I have a couple assistants with me. Well, I would first I would hand each one of my assistants an iPad and say, here, you work on these channels, you work on these channels, and you work on these channels. And I could then assign each iPad and lock out the rest. So if I wanted my assistant to work on 17 through 32, I would lock out this iPad so they can't work on it and hand it to them and say, do not turn that off. But ideally, I would give a password as well. So I think that's a great feature. And now my 16 channels here are locked out, and then I can manipulate everything just on my 32. So it's client-based because it gives you more flexibility. Oh, is this available for MacBook? No, but feel free to put in a feature request to get this available and in. We want to hear feedback on the iPad application before we start working on getting the desktop version up and running. Please put in a feature request, because the more requests we get in for it, the higher a priority it gets. So your voice can be heard for sure. As Steve said, feature requests equals vote for future development. So, and with that, I think we'll close up because we're over time. And we have one more roundtable. And it's important to note that next week, we do not have a roundtable because it's the Thanksgiving holiday in the United States. So please come back next week and the week after on December 2nd. And roundtable 4 will be very fun and interesting. We're going to have Steve Ellison, the founder and inventor of Spacemap. And he's going to talk to us about artistic programming. And we might also have front of house engineer for the band Volbeat and Miguel. His name is Denny Miller. And Denny's been implementing Spacemap in very large scales and doing some very interesting things with it. We'll talk to him about that. And so we're going to talk first about large scale deployments, how to take this and scale it to even bigger space, like a festival or an arena. And that's going to take a few minutes. And then after that, we're going to spend the rest of the time talking artistically about Spacemap and some of the fun things you can do with it. As we said, it's an abstraction. So you can make anything with the Spacemap. You can use your loudspeaker layout, and you can represent your loudspeaker layout in very, very different abstract ways. We'll look forward to seeing you guys next week. Thanks for joining us, and we can't wait to see you in 2 weeks. Bye.